Okay, guys, so you've undertaken a very complex project from many aspects. Mechanically, controls wise, electronics. So, as much as I like your concept, I have to tell you that I find that where you're at is way behind my expectations, way behind your project timeline, and you have much work to do to get caught up.
Welcome to Sabino Industries. If you are watching this video, let me be the first to say congratulations! You have been randomly selected from hundreds of candidates to become our new junior technician. For the past 3 months, our team has worked tirelessly developing our newest product, the Deli Burger. But before we can explain the ins and outs of the Deli Burger, let's first meet the team behind the project.
Hi, my name is Michael Palomino, and I'm the electromechanical engineer coordinator for this project, the Burger Sabino, which is a small automation manufacturing production in order to assemble a burger. My duties were to be in charge working in the lower arm. For instance, developing the motion of the rubber arm, studying the force and the torque that the rubber arm provides, and also finding the angle, position in order to bring accuracy. So, besides that, I was able to help the electronic station and also the heating station. Thank you so much.
Hi, I'm Andrew Young, and I'm the mechanical engineer for our project. That means I build and machine the components. Machine shop is my workplace, and I operate different machines like bandsaw machine, lathe machine, and drilling machine.
Hi, my name is Habib Ali. Our project regarding vertical assembling. I work in the project as electrical engineer. I help with the heating element of the assembly as well as assisted with the wiring and soldering. Functionality of the heater, it has heat filaments, and heater works with the power, AC power. In order to convert AC power to DC, we put solid state relay and we also put K-type thermocouples to detect certain temperature.
Hi, my name is Gary, and I am the software engineer. My job in this project is to program the whole assembly line. Also, one of my duties is to solder and connect all the wires together on the Arduino. And lastly, I create a graphical interface for users to customize their burger.
And I am Nicholas Michael. I was the project manager for the Deli Burger. My responsibilities included creating a Gantt chart, setting up team meetings, assisting with any mechanical or electrical work, and of course, narrating this training video. Now that we have gotten that out of the way, let's discuss our main attraction, the Deli Burger. In order to understand the Deli Burger, we must first break it down into smaller parts, consisting of a software, a heating element, a delivery arm, the topping station, and lastly, the packaging area. Each component was fabricated to work in tangent with each other. To start, we have the software. This assembly system runs on 2 programming languages, C# Visual using Visual Basics in order to create the graphical user interface, and Arduino-based language. The user interface is able to collect data on the user, such as their student number, which allows the Deli Burger to be used in a wide range of applications, for instance, cafeterias, catering, and schools. The software can also implement a payment system and can keep track of someone's preferences when ordering a burger. The Visual Basic software is able to relay information into a serial port for the Arduino, which controls all aspects of the Deli Burger. Once the user picks their condiments and toppings they want on their burger, the assembly process can begin. To start, the delivery arm is a 3D printed robotic arm that runs on a 6001 HB high torque servo motor. It can lower the hamburger box onto the conveyor belt. Next, we have the bottom bun dispenser, which holds the bun using a customized machine arm on an FS 5005 M super high torque servo motor, which can deliver up to 17 kg/cm of torque. The robotic arm will deliver all the toppings and condiments onto the bottom bun to the customer's liking. The robotic arm has 5 servo motors, which enables it to have 5 degrees of freedom. The robotic arm works on a coordinate system to help it find, pick up, and place toppings and condiments. After every time it finishes placing a topping or condiment, it resets back to the 0, position and awaits further orders. The heating element uses heating pads similar to the ones found in a toaster arranged above and below the heating conveyor in order to provide equal heating distribution. The heating pads are powered by a DC to AC solid-state relay, which can receive 5 to 32 volts DC in the input and up to 280 AC on the output, which means it can be connected on a wall plug to power it. The heating pads work on a clocking system to prevent the heating pads from getting too hot and damaging them. The heater is regulated by a K-type thermocouple, which can turn off the heating pads if the temperature inside gets too hot. The heating conveyor runs on a 100 RPM DC motor, the same one that powers the other conveyor belt, and they are controlled by a DC motor driver that runs on 12 volts. Finally, the assembly system is not complete without the top bun. Utilizing the same technique as the bottom bun, 2 servo motors suspend the top bun before releasing it. The final step is to package everything up before giving it to the customer. To do this, we use a servo motor to act as a swivel and the conveyor to allow the box to run into the swivel before delivering it to the customer. Now that we have this out of the way, let's talk about the important features when fixing the deli burger. Inside here is our tidy electrical box, which contains the power supply, a PCB with the servos labeled, an H-bridge, and a DC motor driver. On the top of the panel is 3 buttons. The emergency stop button, or e-stop, is activated by pushing it down. To reset it, just twist the knob until it pops back into position. The dry run button will simulate the motion of the robotic arm, and the reset button below will reset all functionalities of the assembly. Thank you for watching this presentation to get you ready for your job at Sabino. Also, one more note. Don't forget to bring your steel-toe shoes into the machine shop or you're going to have a bad time.
It's time for the moment you've been waiting for.